Hey everyone, welcome to another episode from M3 Engineering. As you can see here, we have Temu Superfly, the Tamiya Hornet Evolution with some additional upgrades. In an earlier video, we saw that I created a set of front arms that brought the front wheel track inboard to make the vehicle look more like the car that it's supposed to, the Tamiya Hornet. There were a number of changes that were done to the car when Tamiya engineered it, and overall, I think it's much improved. The front steering system is fantastic. The transmission, while awkwardly placed and delivering a wheelie every time you accelerate, still gives the vehicle much improved rear handling. There is one area here that Tamiya seems to have tried to fix, but unfortunately additional work needs to be done. So we're going to start by removing the body. Now I pulled off 2 additional pins from the rear wing, and that's because the factory wing with the little embossed areas on the Lexan body typically is ripped off. The design of this part here is not a new M3 product. This has been around for nearly 10 years now, and it will allow you to either 3D print your own rear wing, use a very inexpensive Lexan rear wing, or you can forego these mounts altogether and have a version of this that is completely smooth so that you can use the standard body with the factory wing. Okay, so that system is all tied into the chassis cage. This is not a cosmetic thing. Yes, it does provide a unique look to the Hornet EVO, but it is not simply there for that. It provides rigid structural integrity lost when the Hornet lost the Grasshopper body back in the 1980s. The reason I say that, for those of you who don't know, the Tamiya Grasshopper had a hard molded ABS plastic body, which was rigidly screwed in place here, here, and on the opposite side. What this created was a very strong unibody chassis. The Hornet lost the hard ABS body and gained the polycarbonate body we all know and love. While that did decrease weight and obviously cost, what it also did was take away that second part of the clamshell. This results in breakage, and I'll show you on the other chassis because this has a little bit more stuff in the way. On the standard Hornet, you have a stress riser right there. What a stress riser is, it's basically a sharp edge or a sharp feature that does not allow stresses and loads to be dissipated over a larger area. So the most commonly broken area on the Tamiya Hornet is right there. Now, if you're saying, well, mine's not broken there, either you're not driving it, or B, it's white because the stresses have fatigued the plastic, and give it a few more hard runs, it'll be sheared right off. Every used Hornet in my fleet is either cracked, completely split, or about to. To eliminate this, we have the M3 cage. Now this one here is shown on the original Hornet, but we're gonna look at the one that is on Superfly EVO. It rigidly connects this front part of the chassis all the way to the former mechanical speed control mount here, the rear part of the chassis where the Grasshopper body was attached, and there are 3 screw points, 1, 2, 3, where the original mechanical speed control was. You can see the 3 screws underneath here. This means that from this back part of the chassis to this part of the chassis, you will no longer get that flex in this orientation or this orientation. It massively increases the structural integrity of the front part of the chassis, really leaving only the shock towers, which are another stress riser. But in this case here, Tamiya has added this additional deflection plate. It's quite similar to the one that they had on the original Rising Fighter to reinforce the Super Hornet chassis. This one has been further thought out and I think works, or will work, significantly better to reinforce these towers. There's an additional mount back here in the case of the mechanical speed controls resistor mount, so those are also threaded in place. Here is the rear wing mount. This integrates the back of the shock tower right here so that we now have a fully encapsulated top section to this chassis, even more than the Grasshopper would have been. we have 2 additional screws here, one there and one there. These are a little bit annoying, and I'll show you why. I'm gonna get a standard screwdriver like this one here. You can see that the only way to access them is this way, which is kind of annoying. I've actually got a significantly longer JST screwdriver, which works really well. But if you don't have one of these, we'll talk about some alternatives shortly. The Hornet EVO, however, keeps going, right? We've got this gearbox, and I didn't want this just floating in the air. As you can see from this, I guess from back here, the next nearest mounting point is way up here in the tower. What we are getting is this kind of bulkhead from the, yeah, it goes to the tower. Yeah, from here to there, which helps. But you still have this big moment arm from the mounting point of the gearbox to back here. So a really hard rear mount could eventually fatigue the plastic. And this is very, very hard plastic. Doesn't flex well. It likes to crack. So what I have done, there are 2 mounts on the back of this shock tower that will, again, thread in 2 more screws all the way to this screw here on the gearbox. It's only threaded in on one side. On this side over here, I unfortunately, because of where the screw is actually, the screw hole is coming out on the gearbox, you can see it's not a fully formed hole, which I'm not thrilled about. It's about 70%. And basically, I've used a longer machine screw here so that it protrudes into this area and helps with further rigidity. I've also added these rear exhaust pipes because I found that the structural integrity of the body is actually improved. I'm just kidding, they look cool. You can see that when the body is installed, they butt up right to the back of the body, so no modifications are in order. Because obviously, to install the body, you don't have to modify anything at all. No giant cutouts on the body. Now that we've talked about how to install this and how the system works, let's go into the hardware that you're going to need and some best practices on the printing. The first thing I want to mention, this cage has been available for quite a few years. You can get it on YouMagine as a 3D printed part that you can print yourself, and you can get it on Thangs, which uses Shapeways, to get an SLS material pre-printed part for installation. So in the case of this vehicle here, this is a FDM part printed in, I'm pretty sure this is PLA. I don't believe I had any ABS. So this is PLA. I had no issues with the installation. I did have an early failure right here. I had it printed up a little bit too vertical. So what I did is I basically designed a leg just to, mainly the rest of the print was fabulous. So I hated to throw it away just because of the leg. So I just 3D printed a little replacement piece, glued it in, it's good to go. Is it ideal? No, this car doesn't really get beat up. It's my daughter's car. This to me just saved me time. With that said, it was printed at about a 45-degree angle, basically where this leg here and this leg here were touching the print bed, simply to get it to fit on the, this was printed on a bamboo carbon X1. The alternative would be a pre-printed SLS cage, and that is precisely what Superfly has. So Superfly has the entire cage, exactly the same cage as you saw on the pink car, which, like these Nerf bars, is all printed in multi-jet fusion. My apologies. This is definitely an SLS nylon print that I have gone ahead and painted in yellow just because. I always recommend that you print nylon and MJF prints because they like to absorb liquid. And if they do that, you'll never get them clean again. So go ahead and pick a color. You can even clear coat them if you like. These were all white or gray. And now we've got this color combination going. But again, so you have 2 options. Now, even though I'm mentioning this here, I've already gotten emails from people who are asking about why their standard Hornet cage does not fit the EVO. Again, there have been changes to the servo placement, these shock tower reinforcement pieces, and most importantly, the lack of a mounting place for the M3 upper control arm. Okay, for this car here, we designed the offset 20mm suspension arm that requires an upper control arm link. Well, Tamiya has it on the reverse side, so basically it doesn't need all that. On top of that, the servo actually won't fit. Again, it's in a different location, so this has been re-engineered to fit this car. This won't fit there and that won't fit there. You can blame Tamiya. Moving on. This vehicle here, like the arms, has all been printed on an FDM printer. I didn't learn my lesson the first time, and this roll cage, like the last one, did not print properly. The reason for this, the slicer actually printed the sharp edge flat to the plate with no support. So the support simply, the first few layers simply didn't adhere, and that was the problem. So I made a little, again, adapter so that I didn't have to toss the whole thing. I'm cheap, what are you gonna do? Anyway, that's what happened there. Like the other one, this was printed at 45 degrees. These were also pretty straightforward. How are these printed? It looks like the layer lines are going nearly horizontal. The exhaust tips were printed nearly vertical. I didn't paint these. These are just in kind of a metallic. I thought it looked pretty cool. All the green has not been painted either. This is simply the color of the material. For the installation, at the front, and when you begin your build, you'll kind of notice how much clearance you have here. At the front, I would go for a 6 to 8 millimeter long self-tapping screw. I will not have a bill of material because then people kind of get all hung up on what they have or don't have. Basically, you need just a bunch of self-tappers, and I would recommend in a few cases some machined screws. So let's move on from here now. 6 to 8 millimeter front self-tapping screws. Here you can get away with significantly longer. Usually the Tamiya kits have 12 millimeter screws, so this can go as long as 12 millimeters if you have it. This central one here would do very well with an 8 millimeter. Any longer, it might stick out a little bit, which is fine. It's also important that on all the holes that you tap into, like this one or the ones back over here, you should drill them out with a 2.5 or 2.6 millimeter bit just to clear them out, make sure there's no residual material or support in there, because if you do have one of these holes that's nearly plugged, and by the way, that's the same with FDM, home prints, or shapeways through Fangs, SLS prints, you must clear out through holes, but more importantly, self-tapping tapped holes. The through holes like this one, a 3 millimeter bit's usually pretty easy. If you have to use an 1/8 inch bit, which is 3.1 something, 3.18, that works too. I don't really recommend it, but in a pinch, that'll do it. At the rear, same kind of deal. You're gonna wanna do no more than, if you have a set of calipers, you can always measure. I would go with, yeah, a 12 millimeter if you've got it, which is very easy. We'll do that. For these mounting points here, total pain in the butt. Not because these are hard to access, but because they're hard to access if you shove a speed control right there. So you see what the issue is? I need to get a screwdriver in this way to this Nerf bar upper mount, and it hits the speed control. So just be aware of that. If you have something in the way, I'd remove it and then finagle it in afterwards, which should be a lot of fun with all the stuff here. You're welcome in advance. Okay, moving to the rear, you do not want to use a 12 millimeter bit, 12 millimeter screw back here because it will protrude from the bottom. I guess it's less of an issue here. On the other Hornet, on the standard one, if it stuck out of the bottom, it was possible for the gearbox to hit this. In this case, it isn't, but you can see where the motor wires are routed. The last thing you want is a metal screw protruding in this area. I would use no more than an 8 to 10 millimeter screw up here. Okay, this guy up here, because he is a total pain, I would drill this out with your 2.6 millimeter bit, tap the screw in until it stops. It will, if you're using, what is this? I think that one there is gonna be a 6 or, actually that probably, an 8's probably excellent up here. Maybe even do a 10. You don't wanna try and thread it all the way down because obviously the screw head is compressing on these two legs here. So if you take the legs out, it will obviously bottom out. So screw it until it stops, remove it, do that about 2 or 3 times. This way you cut the threads into the plastic. Now, if you have a screwdriver that is too short, like this one over here, it's actually going to be possible to thread this in. You want to start by putting the screw in, back threading it until it drops into the first slot, and then turn it until it snugs up. Probably the easiest way to do this. In a pinch, I would do the same to the rear, but this one's quite a bit easier to access, I would go with about an 8mm long self-tapping screw there. I use a lot of Phillips head screws simply because the Tamiya already has it, but you can get hex drive hardware as well if you're so inclined. Okay, back here, here's the deal with this. This, I believe I tapped with an M3 machine tap. This is very hard plastic. I do not like using Tamiya self-tapping screws, or worse, machine screws self-tapped onto hard plastic. And yes, Tamiya does that all the time. My recommendation would be tap this with an M3, use a longer machined M3 screw. You probably want nothing longer than, what are we at, 20? No, ooh, that's 26, holy cow, really? I'll be damned. Okay, nothing longer than about a 26 or an inch, okay, from here to here, and that will hold the back in place. This screw here, I believe, is another, you can see it at the bottom right there, right in there. That's a 6mm, non-structural, totally easy. Before you ask, yes, a driver head will fit here without any problem, but just remember, it'll sit slightly lower because usually it's attached to the body, and if you have something in the way, it's possible that it would hit now, but not before. You still have access to your antenna hole right through there. This upper wing mount is designed to use the standard screw body pin unique thing Tamiya uses. It'll just tap right on in there. For the wing mount, this is also unique to this car here. There is a through hole, this little part right there, that's a through hole. You'll use the upper mounts, the upper screws up here with a washer straight through, so they protrude on this side. And I've used a this is actually one of those Tamiya serrated nuts. You can use a washer and a lock nut as well, and that will secure this thing firmly in place as a load-bearing member of the rear shock tower. That width can be, I would go with 18 to 20 millimeters. Should have no problem with that. The nut's a little bit finicky to access, but you can do it. So all of this, if you go with this tower set up here, will fit under the body minus the wing and the wing struts. If you go with the flat version, it'll fit with the stock body. One more thing that I'm going to include with not only this STL file as well as this STL file is the power switch mount for the kit ESC. You can see it right in there. Okay, this is using an M2 screw, about 8mm long, with a nut. Is it a nut on the other side? No, actually it taps in. This actually taps directly into this. So it's a machine screw tapping into this little tiny hole, which is fine for this. The screw is then held in place. I believe those are standard. They are, yes. These are 6mm self-tapping screws, and this gives the power switch a proper location to live and not double-side taping it somewhere, which is very upsetting. So basically, yes, this will fit with the inexpensive, this is what, the Hobbywing 1060, I think it is. I forgot. Anyway, my friends, that is it. This is one of my favorite modifications because not only does it reinforce some critically weak areas on the Hornet, but I think it just looks cool, right? I mean, I dig the whole cage look. Every single Hornet in the fleet now has this cage. In fact, I'll show you another one in a sec. But just please remember that the standard Hornet cage will not fit this car. It is specific to the Hornet EVO. I also get a lot of questions if this fits with the Grasshopper body. As I mentioned earlier in the video, no. The Grasshopper body occupies every single one of the screw mounts that this chassis takes advantage of. So there is no possible way to make this cage fit the Grasshopper, nor would it do anything because it simply already is doing what this is facilitating. So if you look at my son's Hornet, which he was just driving in the dirt yesterday, excuse me for the dirty Hornet, pull the Beetle body off and you can see that even on this car, here we'll pop that off. So this is an early prototype of the Ampro cage. This is SLS nylon, I just painted that silver. And then I went ahead and massively over-engineered this contraption at the front, which clamps onto the front part of the cage there. And then up here, which clamps onto about 50 different points as well to adapt the Beetle body like so. So yeah, this I believe is also an ancient, yeah. In fact, you can see on this one here, Oh yeah, there it is. Look. Okay, you see this? This was broken completely in half. That's actually super glue. Same with the front right there. But because of this chassis cage, there's no longer any significant stresses there, and therefore we're able to continue to use this chassis. And believe me, use this chassis, we do. Anyway, my friends, thank you all so much for watching. Again, there will be links for these components through Thangs, which will give you a couple of options for the materials, as well through YouMagine, which will have most likely everything in one download. Thank you all so much for watching, and we'll see you next time.